over 16 through the rest of the package. That this is useful. For the GCF, nine. Well, this is going to be 9 times 4, which means that the GCF out of both of these numbers is 9. Okay, and I did a little factor tree there. Second, for the letters. One way I've done it in my class, and if you need this, feel free to use it. If you don't need it, that's fine, just ditch it. But one way I did this in my class is I listed out all the x's and all the y's that were available to me, and I circled them, but they both had in common. So this had 2 x's and this had 2 x's. So the most x's I could take out of each term were 2 of them. So there's 2 x's that come out. Now, what's left inside? Well, what's left inside are these 3 y's, this minus sign, and then it looks like these 3 x's. And that's it. It's colorful, but that's your answer for 16. Number 17. So let's look at numbers first. So for the numbers, we have 15, we have 30, and we have 25. Well, on the top of my head, I'm thinking that they're all multiplied by 5, so I'm going to take a 5 out of these. Okay, and what's left inside here? So sometimes I have students that actually divide each of these by 5, and I put 3 there because that's the other problem. So let me just put a 5 here. So if I put a 5 here, and I put a 5 here, and I put a 5 there, and I'm actually going to move this over because I might have more stuff coming out. Okay, well, what's left in the first one is a 3, and then it's going to be plus a 6, and a minus a 5. I don't know what else is going to go there so far, but let's keep going. So for this part, I got 5 x's, 2, 3, 4, 5. I also have 4 y's, 1, 2, 3, 4. For my second term, I have 7 x's, 2, 3, 4, 6, 7, and 2 y's. And then for that looks like an x. And then for my last one, I have 1 x and 1 y. So what's interesting here is I wrote all this out, but it looks like where I'm really going to end up going is I'm going to take out 1 x and 1 y from each one of these and leave the rest, because all of these have 1 x and 1 y. So take 1 x and 1 y out of each one of these, and I can see here now that I am just left with 4 x's in the first term, so x to the 4th. I'm also left with 3 y's, so y cubed. For the second term, I am left with 1, 2, 3, 4, 5, 6 x's, and 1 y. And for the last term, well, there's nothing left over, so this is my final answer. Okay, let's go on to the next one. Oh, I love these. This is the Foster method. So this is a trinomial. There is no GCF I can take out right off the bat, but I can take a number times a number to be equal to a positive 24. I also can take a number plus a number and see if I can get that to be negative 10. And I'm thinking it is, it's either 12 and 2 or 6 and 4. 12 and 2 or 6 and 4. And it's looking like it's going to be negative 6 and negative 4. That works for both of these. So my final answer when I factor it is going to be x minus 6. And it's going to be x minus 4. And I'm done. Okay, let's go on to number 19. Now number 19 looks a little strange, so what I'm going to do is I'm going to write it slightly different. I'm going to say it's x squared. I'll put a minus 81 here, but I'm also going to put a plus 0x. Just so that way I remember that if I ever see a problem like this, I can actually make it look like the other problems by adding in the term that I don't see. And now that I know that, I can go right back to the Foster method again. I'm going to need a number times a number to equal negative 81. I'm also going to need a number times a number that's going to that's a number plus a number that's going to equal 0. And let me see here. A number times a number. I think it's going to be negative 9 and 9. It's supposed to be in red. Negative 9 and 9. 9 and 9. Perfect. So my answer is going to be an x goes there and an x goes there to get the x squared. And then I have a minus 9 and a plus 9. I didn't really talk about that last part, this part here with the x and the x. The reason I put this x and I put that x in each one of these is because when I multiply these together, I get x squared, which is what I want. Alright, let's go on to the last one here. Oh, and by the way, this is the answer here. I didn't box it in, but this is definitely the answer. Alright, number 20. So remember GCF first, if possible. If you can't do the GCF, then you just gotta move on. So let's look at this problem, number 20. And I'm just looking at the instructions here. Okay, number 20. I'm going to take the GCF out first, and I noticed that I can take a 3 out of each one of these. So let's take a 3 out. Let's see what we get. If I divide everything by 3, I get x squared plus 13x plus 40. I notice that I can't take anything else out. Like I cannot take out any x's because I only have 2 x's here, 1 x there, and 0 x's there. So I could only take out a 3. But what I have left here is something that I can factor into the Foster method. So I could do something like this with an x here and an x here. And then I could go ahead and see what plus what equals 13. I could also see what times what equals 40. Same two numbers. If I think about it, I'm thinking 5 and 8. A positive 8 and a positive 5 get you positive 13 when you add them, and a positive 40 when you multiply them. So the numbers that will go here are x plus 8 and x plus 5. And that is your answer. There's nothing else you can do about it except that. Let's go into 21. Now 21 looks a little bit tricky, but all the numbers are even. And if all the numbers are even, that means I can actually take a 2 out of each one of these. And let me just put a little line here so we can separate our work. So now I'm going to put my 2 on the outside of the parentheses. And I get an x squared when I do 2 divided by 2. 24 divided by 2 is a 12, and there's a minus sign with it. 72 divided by 2 is 36, and there's a plus sign with it. So now what I'm looking for is again, I have this opportunity here where I can break down the problem a little bit further with the Foster method. And the Foster method, again, if you're not sure, is a number times a number equals 36, and a number plus a number combined with a number should be equal to negative 12. Let me think here. The factors are, this one I don't really know off the top of my head, 9 and 4, or it could be 3 and 12, probably not 3 and 12. It could be 18 and 2, that's a good one. It could be 6 and 6, oh, that could be the winner. 6 and 6, I like 6 and 6. 6 and 6, it could also be 1 and 36. But it actually can't be 1 and 36. It has to be 6 and 6, because 6 times 6 is a positive 36, and negative 6 and a negative 6, equals negative 12, so these actually have to be negatives to get that negative 12 and a positive 36. Thank you. The things I put right here are going to be x's, 2 x's, to get the x squared. And then I'm going to go and put a minus 6 and a minus 6. And that's my answer. I could also rewrite this answer in a shorter way as 2 parentheses x minus 6 squared. Either one of these answers would be fine. I'm just writing both of these down for you. because I'm feeling pretty nice at 1 o'clock in the morning. Okay, here's the next one. 22. Now 22 looks pretty harmless. I just need a number times a number. A number times some number to equal a positive 20 because I have to do the Foster method here. I also need a number plus a number. A number plus a number equals negative 10. Okay, now let's see. For 20, the factors of 20 are 1 and 20. Oh, don't die. 1 and 20. 2 and 10. And 4 and 5. Okay, and to my knowledge, I don't think there's any others. Oh my gosh. Oh my gosh. Oh my gosh. Holy moly guacamole. Not factorable. Okay, that's your answer for 22. And sometimes you may get those. When the Foster method fails, that is not factorable. Now, technically, you could pull a 1 out. So I would also accept an answer of this and talk to your teacher about what you would want to do here if this was the case. But you could technically also have this as your answer. Okay, that's not wrong. Either answer would be fine. And now let's go on to the next page, 23 through the rest. So these were common mistakes that were missed on the last test, and I want to make sure we're clear on these because they're going to be on the next test, so let's just do it. Negative 6 squared. Well, in my class, we made a big point of this, and I hope you did in yours too. This one on the left, negative 6 squared, means that there are two negatives being multiplied together. A negative 6 times a negative 6. Well, negative 6 times negative 6 is a positive 36 because I have two negatives. On this one, I have a negative 6 squared. And what that means is I'm going to have a negative 6 times 6. So here, only the 6 is squared with one negative. In the other one, the negative 6 is being squared, which is why we end up with a positive 6. So which of the following is the answer to negative 6 in parentheses squared? And your answer is going to be 36 when I multiply them together. To simplify the following exponent expression. Now, maybe you're one of these people, but I'm going to write this down in words just so we have it. We don't just move anything that's negative to the opposite side of the fraction. Only move negative exponents. And you'll notice that negative 15 is kind of all by itself, actually. So negative 15 is just going to stay, and I'm just going to deal with x to the negative 3. Negative 3, when I deal with that, ends up going to the bottom with a positive exponent. And I could put a 1 on top, but I also could put my negative 15 on. My negative 15 is not going to the bottom because it does not have a negative exponent. So my final answer should be C. For 25, I think most students in my class got this as 1, which is great because anything to the 0 power is 1. So let's just write that out. Just anything to the 0. But that won't be in this class. Anything to the 0 power is 1. So the only part here that we need to be aware of then is going to be 10 times x to the 0. And again, this is going to be a parentheses thing. If I box in 10, 10 is not being raised to the 0 power. So it's going to be plus 10. Then this x to the 0 in green is going to be times 1, which is going to be 1 plus 10, which is going to be 11. Again, the reason it's not a 1 plus 1 here is because here is how I would get the answer of 2. If I had something like this, 8xy squared to the 0 plus 10x to the 0, well, each of these would be a 1, and then I would get 2. So notice again, watch the parentheses. And finally, what is the answer of 2 to the negative 4? Well, we kind of just did this one, but I'll explain it a different way. Please remember that whenever we have a negative exponent, anytime there is a negative exponent, fancy way, very fancy, so a negative exponent so in other words, for 2 to the negative 4, well, 2 to the 4th is 16. And you could check that out. Which means that when we put a negative exponent here, it does not make the answer negative. So just because we have a negative exponent does not make the answer negative. In fact, what it does is it says, please just flip the number around. So before we had 16, and now we're going to have 1 over 16. And again, a different way you could think of that is anytime you see a negative number, a negative exponent, take that number and move it to the opposite side of the fraction and put a 1 on top, which gets you 1 over 16. I sure hope this helped. Thanks for watching, and good luck on your upcoming test.